right, ladies and gentlemen, hello and welcome back once again to the only coast to coast show that's all about the information economy. It's called Inside Analysis. Yours truly, Eric Kavanaugh, here with our good friend, the evangelist, the tech evangelist. This guy knows almost everything, at least about data and systems and troubleshooting and all that kind of fun stuff. Kevin Kline, tech evangelist for SolarWinds, is with us, and we're going to talk about the foundation of the information economy, and that is still the database. Yes, there's data fabric, there's data mesh, there are all these different ways that you can store and persist data, but the database is still the foundation, and it's going to be the foundation for quite some time. And I was mentioning to Kevin before the show, with database performance, well, it's the kind of thing where is if it's not performing, you're not happy, and other people aren't happy. The system is slow. It just disrupts the workflow. It causes morale problems. It causes all kinds of issues, and people get very unhappy. And understanding all that is pretty darn complex and has been for a long time. Like really getting into the weeds of knowing why is this database having trouble has been difficult. But we've seen this trend the last few years of observability. I think a lot of it was kickstarted or at least jump-started by the Kubernetes movement because Kubernetes came in thanks to Google, and you had containerization. We had Docker before that, but Kubernetes really won that war. And because of Kubernetes, we have this explosion of observability vendors. So it's fun. We're getting to the place where we can see. And now the question is, what can you do about it? How do you understand what's happening? And what does all that mean? And that's what Kevin Kline is going to tell us about. So, Kevin, welcome back to the show. Tell us about what's happening from SolarWinds on the database performance side.
Well, great to be back on the show, Eric. Thank you for having me.
Yeah.
The with SolarWinds, we have a large number of customers, hundreds of thousands of customers, many in the Fortune 1000, very large entities, but we also have a very large number of small and medium-sized businesses, businesses that frequently do not have a database administrator on staff. And so one of the things that we're seeing is that, as you mentioned, the complexity of our systems are so great now that even if you're well informed about what, let's say, your in-house application does, you're one of the developers on the team or sysadmins who help deploy it, and it talks to a database, you kind of think of the database as a black box. I send it select statements and inserts and updates to operationalize the data that this particular application does for us. Maybe I write some reports and then I keep my fingers crossed. And so one of the things that we see in those small and medium-sized businesses is that there's a real shortage of expertise. So it's not uncommon for a team to have very experienced developers who have been working with their chosen software language for years, decades, and they're great at it. But once it comes to that database, they know how to write SQL, but maybe not very well. And so, like you said, getting to the point where you have a slowdown, it can be really surprising and uncomfortable for these organizations, because how do I troubleshoot it? How do I even make sure my team is aware that things are going sideways in advance, rather than learning from my phone blowing up and my end users calling very angry that something is wrong? And so I'll be honest with you, I blame academia, which is yeah, it's kind of funny. My brother's a professor, so it's a half joke because I like to stick my elbow in his ribs. But I when I went to college in the 80s, I got a bachelor's degree of management information systems, and there are similar names today. And the other main computer-oriented degree at that time was in the School of Math and Engineering, and it was computer science. And so if you graduated with it, even today, a degree in computer science, we pretty well know that you're going to have certain understandings. You're going to have a certain baseline of knowledge. But there is no bachelor's degree of data management. And so what we find is maybe we're lucky in the interview process that we have hired someone or are considering hiring someone with a certification, because now we do have a baseline understanding of what they know. But that's not common. Even the certifications aren't that common. And so we find ourselves in a situation in which you might have someone who gives you a resume and it says they have 5 years of database experience. You think, oh, that's pretty good. That's the best we've seen so far. But in fact, they actually have 1 year 5 times over, right? So they know how to back up a database and they know how to troubleshoot a simple select statement or something, but they're really not solid database professionals. And that's something that is really, really tough because, as you said, if the system slows down, we can measure the impact of that in dollars. Either,
Wow.
we're not getting enough sales transactions through. People are leaving the website because they can't put things in their shopping cart in a timely way. So we even say slow is the new down. And
I've
yeah,
heard that. I like that. It's
yeah.
true. It is the new down. Yep.
And so our tools build in a lot of that kind of global high level expertise of database professionals and make it much easier for you, not only to see metrics that you may not even know exist, but it puts them in light of what meaning do they convey, and what's the resolution when you see a particular sort of problem.
hmm And there are lots and lots of things that can go wrong, especially with a large database or a multi-node database. For example, we have all these distributed databases these days. There are issues with the RAM, there are issues with spinning disk, there are issues with the network, you have network latency. And this is why it gets complex because you have 5, 7, maybe 12 different factors that are coalescing to create some shortage. And even just a handful of years ago, I mean, you had to have an expert to be able to look and say, CPU usage is going up, but memory is low, and the network is at this place. Oh, I know, it's probably this node failed or something.
Right.
Point being, you had to know a lot to even know which questions to ask and where to go. And that's starting to change now, I think, because of this observability, because of automation. I mean, even things like configuration settings, one weird little setting in there somewhere can cause you a lot of trouble, right? So how does this technology address some of those issues? Are you able to automate some of that stuff or maybe just get into the weeds a bit?
Yeah, we do look into all of those sorts of things, and as you pointed out, it's just so much more complicated than you might think at first glance, and that's even made worse because the paradigms, mental models that we use as developers are often at odds with what database designers use. So databases are designed around sets of data. You write a select statement that has a from clause and a where clause, so I
Right.
want everything from this table where it has these characteristics. But developers tend to write their code to address one line of data at a time.
Hmm.
And when you do that, that makes your database super slow. So
Interesting.
yeah, so we have in our different products, we have tuning advisors depending on the area where the difficulty might be found. So for example, in Database Performance Analyzer, we have index tuning advisors. So it could say, based on this workload, say from 8 a.m. on Monday to 5 p.m., the normal workday, these indexes aren't used at all. And these other indexes are really not best for the workload that you have.
Hmm.
We have table advisors. And this is important because many times I'm sorry, not DBAs so much as developers will choose a poor data type for the kind of data that they need to store.
Hmm.
So a couple of very common examples there is to use a GUID as your primary key.
Hmm.
Now, GUID sounds great because it's a global unique identifier, and your primary key is your unique identifier for the records in a table. But the problem is GUIDs are typically 16 bytes in size, so you can get a unique identifier with a big integer data type in a much smaller space. That's the first problem. But the second problem with GUIDs is that they, because they're so unique, they just scramble all your data across, I guess you could say, logical fragmentation. And so
Hmm.
It's particularly bad on spinning disks, and it can be much, much slower, particularly for things like insert and update operations on SSDs. And then finally, we have the query tuning advisors. So it says, based on this workload, and you have these different select statements and so forth, then if you add an index onto or change the columns in an index, all of these queries will see at least a 10% improvement in performance. These other queries will benefit from having an entirely new index added on. So we give you a lot of really prescriptive, detailed information about how you can make your workload better.
Well, that's very interesting because to create the indices strategically can make a huge difference. And that requires to know what questions people are going to be asking. So what you want to be able to do is monitor what questions are being asked and then dynamically provision or at least suggest. And it sounds like that's what you're doing, right? You're
Yeah,
watching what's coming across the transom and then having the system say, we see you're doing this. We recommend creating an index on this particular dimension. Is that about right?
exactly. So, for example, your primary key in one table, you'll want that indexed, but it's going to probably be a foreign key in another table.
Mm-hmm.
For example, you've got your sales order detail table, and people will order different products. So
Mm-hmm.
the product table will have its primary key, but your sales order detail will have a foreign key to make sure that nobody puts in products that don't
Right.
exist.
Right.
But it's a very common thing for developers to say, oh, I need a foreign key, but they don't remember they have to also separately add an index to that.
Interesting.
Right.
So,
So
and
this will come back and tell them those sorts of things.
right, and so it's interesting because what you're referencing is an information architecture and
Right.
things like data modeling. And data modeling, I always used to try to wrap my head around it. And really, it's all about optimizing the performance of the system for the particular use case. That's why you spend time modeling data, is because you want to ask yourself, okay, how are we going to be using this information? We want to enable the customer to search for products very easily. So that's creating indexes. But then we want them to be able to go and buy stuff. And I often explain to people why, when you're in Amazon searching for stuff and then you go to buy something, it switches over to this whole other system because that system is transactional in nature, is designed to capture the money and actually order the product and send it on its way. It's a different system from the searching system where you're looking
Right.
for stuff because these environments have been optimized for the functionality involved. And that's why you switch from this system to that system, right?
And in fact, that's, part of the whole discussion around, should I use a NoSQL database or should I use a SQL relational
Right.
database?
Right.
All the relational databases, their genesis was back in the 70s, when we didn't even call it information technology back then. We just called it data processing. And we just did what scientists and accountants did, only faster, right?
Wow.
But those were all systems, typically, like a banking system. And that was all run on batch mode processing on mainframes. And if your mainframe happened to lose track of a few records of your data, which they would often do in the 70s and early 80s, people were not okay with that.
Right.
They'd grab their pitchforks and their torches and march on the castle and burn it down. So that's why they invented those relational databases. The whole premise of a relational database is built around what's called the ACID
Hmm.
property of transactions. It must
Hmm.
be atomic, consistent, isolated, and durable. Most of all, durable, so that if that mainframe crashes, um, I can recover the transaction either all the way to completion, or I can roll it all the way back so that you don't lose any money.
Right.
Now, on the other hand, we have, the newer generation of NoSQL databases, which are based on the CAP theorem. And it comes from CAP theorem, consistent uh, and partitionable. The idea there being that we can eventually be consistent. The first of the NoSQL databases, Hadoop, was created by Yahoo. And the
Hmm.
idea was, I'm going to post a picture of my cat. and people's money doesn't depend on that. And my grandma will see it eventually in Southern California, and I live
Right.
here in Nashville. So, in the next few minutes, it'll get to her. But we find that, people will choose a NoSQL database for reasons that don't play to its strength.
Hmm.
And so one of its strengths are the incredible speed of lookup. And so that ability to search for what you want, that will often be in a NoSQL database,
Right.
maybe Redis or MongoDB. But the placing of the order, where it's money, that's going to happen on a relational database.
That's right. No, that's an excellent point, and this is, I think, what people have to understand. And to your point earlier, a lot of times maybe the developers don't fully understand that, and this is why it is so important to have someone who knows what they're doing in the early stages, because database migration. You use those terms in a company that has a large database, that is a transactional database, a production system. Let me tell you right now, you will just send shivers down the spine of all the operational people. They'll be like, "Oh, good God, please don't do that." No,
That's
because
right.
it's just hard as hell to do. And there are all
Mm-hmm.
sorts of things like nested tables and remote procedure calls and things
Yeah.
like that baked into the system. And if that's not all documented very, very well, when you migrate that database, you're going to have all kind of problems that are going to crop up, and you won't even know the problems is the real issue, because it's going to take weeks, even months, maybe a year later. Something terrible happens. Well, why did that happen? Well, I don't know. If you look into it, oh, when we did the migration, they didn't dot this I or cross this T, and
Right.
that's the issue. But folks, we got a break coming up here. We'll bring Kevin Klein back in the next segment from SolarWinds. If you want to be on the show, send me an email, info@insideanalysis.com. That does come straight to me. We are booking out the second half of the year right now. Yeah, the second half of the year is already here. It's kind of hard to believe, but we'll be back here in just a moment talking to Kevin Klein, tech evangelist from SolarWinds, about database analyzer and understanding why these things are not going well. And if you're wondering when you see it as a consumer, it's when you're on the phone and the lady says, "Oh, our systems are running slow today." Like, that's often why. It's the network, or it's the database, or it's the app, or it's something. But we'll pick that up after the break. We'll be right back. You're listening to Inside Analysis. All right, folks, back here on Inside Analysis with the inimitable Kevin Klein, tech evangelist for SolarWinds. We're talking all about database performance and observability and understanding what's happening. And Kevin, you made a really good point in the last segment about the different kinds of functionality. And, you might appreciate this. Back in 2005, I interviewed a guy I'm sure you know named Dr. Michael Stonebreaker,
Of
who
course, yes.
invented the modern database in many ways. And I remember he was on this whole push of one size fits all. And his
Hmm.
point was that one size does not fit all. And what he was saying is that up until that point, relational databases had just ruled the day, and everyone used the relational database for everything. And his point was, it's good for some things. It's good for ACID transactions, like you talked about. It's good for data warehousing, and it employs set theory, basically. But he said for some particular purposes, it's not optimal, like analytics. And he talked about a column-oriented database. And why that's important is because in the columns, you're supposed to have the same kind of information, so you can compress it very easily to
Yes.
move it around and to do analysis on it and things of this nature. And there are lots of other kinds of databases. There are object databases. There are graph databases that have really come to prominence in recent years, in part thanks to Facebook and LinkedIn and Kevin Bacon's 6 degrees of separation, all that kind of stuff. For those kinds of queries, graphs are very, very powerful. They're kind of slow, but the point is, you want the right database for the right purpose. And now we have like 420 databases are listed at dbengine.com. That's a lot.
Right.
It's a lot. And so it really pays. And I mentioned this in the last segment. Before you actually launch your application, your production system in your organization, you really want to spend time thinking about, what do we want this thing to do and which database should we use? Because to your point, the performance will be 100x on this versus that, depending upon the use case. So, how do you help clients, and how does this new technology help clients make better decisions about that?
Well, one of the things that we know, if we talk to social scientists and to neurologists and so forth, is that people aren't really good at remembering uh, discrete facts and details. Um, that's why they encourage us so often, and something that you're a master of, is to tell stories,
Hmm.
because people remember stories much better than a list of
That's
tabular
interesting.
numbers. And so in the same sort of way, the human brain is extremely good at finding patterns to match to. And the flip side is we're also good at seeing when things don't match the pattern that we expect. And so we basically codified that into a database performance analyzer, in which we have anomaly detection. The longer you're able to watch a system, a database system, the longer it's able to build a kind of a corpus of knowledge of what's normal for this
Hmm.
database.
Hmm.
So it might be normal for a CPU to spike every night at 1 a.m. for 30 or 45 minutes because some important kind of off hours task runs. So it won't give an alarm to anything like that. But then suddenly, on some random Wednesday night at that time, we have 300 user connections when we don't normally. Well, that's an anomaly. Um,
Right.
Even if we didn't blow up the CPU or consume all the memory, there's still something very different about this workload. And so the tool is able to point out anomalies to you, which is so much easier when we're dealing, especially with people who don't know a lot about technology. And of course, I'm speaking about our business users. So if you work in corporate IT and you're on an application team or a DBA team, and someone on the business side says, "Why is our application running so much slower?" Uh,
Hmm.
if you were to talk about context switches and page latches and their eyes will glaze over instantly. But if you're able to say, well, I guess we opened up a new office because it seems like we're getting 20% more activity out of the southeast of the United States than we got at any time in the past. Well, they instantly understand, oh, yeah, we did roll this out to our stores in the southeast. So it becomes part of the story, the narratives that we know about our application. Instead of details and figures, we can
Right.
quickly look at the tool, we see a pattern match or mismatch,
Right.
and it gives us a context of what that means, and we can respond accordingly. We may not need to fix anything
Right.
because that's just part of the business.
Right.
On the other hand, it's like, oh, our server is under provision. We need to put a little more hardware in
Well, and I mean, these are all really important issues because you had that line I love earlier, slow is the new down, right? I mean, you don't see too many, at least public facing databases crash anymore, thank God, right? So we've kind of solved that problem. But to your point, when it's running very slowly, well, what happens? They get frustrated, they move on, they do something else. Certainly in an e-commerce environment, you've got to be snappy as heck. And I remember talking to one of the industry analysts out there, and they said this was an absolute prime directive at Facebook was to make sure it's snappy. That's why they built their own database, right? Cassandra. They just went ahead and rolled their own, and you've
there.
kind of seen that over the last number of years. And it's really funny. I mentioned Stonebreaker, and this when he said one size fits all. From that point in time, if you look at the explosion of database technologies, it's really remarkable. I mean, you've got MongoDB, you've got Redis, you've already mentioned, you've got MariaDB, which is the old MySQL. That's one of my favorite stories in the business, or what's his Montevidenius, right? So the
Yes.
guy who ran MySQL, it gets bought by Oracle, Oracle buys Sun, and the next day Monty forked the project to MariaDB. He's like, I'm out.
Yep.
I mean, how funny is that, right? So to the consumer, they're like, "Oh, what are you talking about? It's just crazy stuff." But the reality on the ground is that it makes a big difference because now businesses have options. And I've had this theory that a lot of the open source stuff was all targeting Larry Ellison. They're all like,
Right.
give me a piece of that pie because Oracle
Uh-huh.
had so much business. I mean, they were just
Hmm.
crushing it. But then, they have a bit of a strong arm approach on
Yes.
lawyers rapping you on the knuckles, and nobody likes that stuff. I mean, Microsoft would do that stuff. that's not good for customer experience, right? What do you think about that theory that this open source explosion happened in part because there was a lot of static from the old database world?
Oh yeah, and it's true. I was in the past, I was the president of the big International Professional Association for SQL Server. And at that time, a person I know you've interviewed, Bob Mulia,
Hmm.
was the VP for the data platform at Microsoft. And back in those days, say 2005, 2006, their biggest worry was this explosion of open source databases that
Right,
was a winning favor with the dev community, not just winning minds, but hearts.
right.
And so that was one reason why we were able to talk them into giving more support to the user community, because that
Interesting.
was that was our main goal, was to get people enthusiastic about SQL Server. And so yes, that is the community around open source is a threat to the big commercial platforms. And in fact, you mentioned DB engines a while ago. uh, I believe a big part of the reason that Postgres is seeing and enjoying a very big boom lately is that it's really easy to switch from Oracle to Postgres. And so
Interesting.
a lot of people are like, I like the Oracle database. I personally worked on it for 7 years and loved it, the technology. But when those salespeople roll up in their BMWs and have a fountain pen and a bunch of papers in their hand, people run for cover because we're gonna have to redo our licenses, and have an audit. So yes, very true. Another thing you mentioned in passing, which I'd like to touch on too, is that one of the things that happens in our world as database professionals, as I mentioned, there's there's a real shortage of expertise. And so one of the things that is maddening to a person who's really serious about databases is that mistakes that were solved decades ago, like when I started in the 80s, we knew about SQL injection. We knew how
Hmm.
to fix it. And yet, what is one of the most impactful hack that we see being performed today? In the not the most common hack,
Right.
not the one that we see used in by the millions. That would be something like a DDoS attack. But the one that has the most impact is SQL injection. Still,
Hmm. Hmm.
and to use an analogy, it's like leaving the door unlocked to your house. I mean,
Right.
just lock the door, folks. We know how to deal with this problem, and
Right.
yet it still comes around.
That's interesting, and it's kind of an embarrassment of riches these days, in that you have so many options, and it's darn near impossible to stay on top of things. Although I will say this juggernaut called Gen AI is getting pretty interesting, and I've been studying it very closely over the last, I don't know, year or so, I guess. And what I find, and I'm curious to hear your thoughts on this. What's very interesting about it is that people have to remember these are really consensus engines. That's what these models are, and so for any topic that has been widely published, they're going to be really good at getting consensus from all the different papers about how a PostgreSQL database should be designed, about
Sure.
a good data model. In fact, one of my good friends, John Ladley, we were joking the other day about how in the professional world, in the data world, like you'll have a bunch of data architects. Let's say for some insurance company, you might have 20 data architects, and his point was in 3, 4 years, you're going to have like four,
Yeah.
because you can use these tools, and the tools will give me a data model for a retail company selling 127 different products and this and that. And it'll be like, okay, and it'll show you. And that's a good starting point. So, and it also can help you analyze code. There's
Right.
all this talk of no COBOL developers around anymore. What's like, these Gen AI engines, they can do really interesting things, and they can get you like 80% of the way to understanding things. It really is a new sort of co-pilot for people to use as they're in the database world. What do you think?
It's going to change everything. It really is. And one of the ways I think we should just spend an hour talking about this.
Right.
But you had mentioned how relational databases, are the workhorse of corporate IT, and yet they are actually only about 20% of data that is
Hmm.
retained within an enterprise.
Right.
whether you're a government agency or university or a business. The majority of your data is actually in Word documents, memos, emails, Teams, Slack discussions. And that is something that Gen AI is extraordinarily good at ingesting, especially when you're using something like a RAG approach where you're using retrieval augmented Gen AI. And so you can do things like, what is our internal, you can write basically a prompt, a query that says, what is our internal take on this particular technology challenge? And you can see what everyone in the organization has had to say about that.
Wow.
And, it's just amazing capable, and it's quite funny too, because sometimes what this does at the end of the day, at least for those early adopters, I have a friend who works for an important but not well-known legal company, and they came to realize they didn't have very good data governance in place, because when they asked Copilot, they'd let it go out and crawl through their SharePoint sites and their OneDrives and all that. And
Right.
and so people on the team were like getting information back from the CFO's office and from the internal auditing team, and really very sensitive data that shouldn't be
Wow.
allowed.
Oh,
And
no.
that was all because the people didn't tag things. Um, our systems, unless we have designed them otherwise, are based on the idea of trust. And that's why we
Yeah.
get hacked so much. So if
Right.
you're like, okay, my OneDrive and my team's OneDrive accounts are all owned by them, nobody else can see them. You're just living on a prayer right there.
Wow.
And so once you crawl it, if you haven't designated that already as something that only the CFO team can see, then
Right.
other people will see it. So it is revolutionary, but it is also something that we need to to be careful about. Just like you said with normalization,
Right.
I like to say that a plan never hurts, and it usually helps. So,
Yeah. Right.
so if you go into it with a plan, you're usually going to come out much better. So
Well,
that's where we need to be.
I think it was it Eisenhower said, I've always found that plans are useless, but planning is indispensable.
Yes, that's
I
right.
I think it's a good one, right? Because in the process of planning, you will think about many different contingencies, and then at some point in time, that's going to pop up, and you already have an answer in your head, or at least you've thought about it ahead of time. So, there is this danger of planning too much and then sticking to the plan no matter what happens. And especially these days, boy, you have to be very careful about that. Agility is the word of the day, and actually, we'll pick that up in the next segment as we talk about this technology a bit more with Kevin Kline. We'll be right back. You're listening to Inside Analysis.
It is.
All right, folks, back here on Inside Analysis, talking to Kevin Kline, not the actor, but I think he would probably do pretty well in the acting world because he's got charisma and knowledge, and he is the tech evangelist over at SolarWinds, and they've got this whole new product upgrade they're talking about with Performance Analyzer for databases. And Kevin, there are a bunch of really interesting things in here. Migration support, tuning advisors, root cause analysis. I mean, to be able to get to the bottom of something quickly is really important in systems administration, because if you don't, you could spend days spinning your wheels, and it's very frustrating. It's very bad on morale. So if you're monitoring things, if you know what a baseline is, and you've got these tools to kind of help you, I think that's really where a lot of this automation and machine learning is going to come to fore, is in recommendations, right? There's an old expression. I love this one. It's an old cliche that says, man doesn't need to be taught so much as reminded. And I think that's what these engines are going to be very good at. And I'm guessing that's a lot of what this technology does that SolarWinds has put out, is it says, hey, you know what? You should look at this, you should look at that, you should look at this. And that's incredibly useful. What do you think about that?
Yes, absolutely. And particularly because the depth of skill out there in the market is not as deep as we'd like. So, for example, in our SQL Server core product called SQL Century, we our team had 7 Microsoft MVPs, most valuable professional accolade. we were so serious about getting the best wisdom, the best knowledge for recommended course of action in certain problem situations.
Hmm.
And in the same way, we do that with our heterogeneous database product called Database Performance Analyzer. We tell you, here's not only what we found, but here's how you should respond to it. If you're curious, a lot of our customers say, I want a button that says, do what I recommend. Just click it and go out and do it. But the problem is culpability in that
Right.
situation. So we don't want someone to come back and say, oh, well, I clicked a button and it didn't work right, or it made things worse. So we have to take the position in which a responsible party inside of your organization will make those changes. But we give you everything you need to do that.
Yeah, that's good stuff. And SQL optimizers, I talked to a bunch of database experts over the years. One of my best friends in the business, Mark Madsen, he told me one day, he said, if you build a new database, it'll take you 10 years to find the edge case that'll crash it. Right, and that's an
So true.
interesting warning sign, right? Which is like, wow. And there are lots of new databases. I mean, there's CockroachDB, there's DynamoDB, there are all these databases out there. And that's again part of the challenge is that you go on site somewhere, they could have 5, 10, 12 different database technologies. You may know a lot about this one or that one, but being able to get help on that array is very, very compelling. And let's just kind of dive into the SQL optimizer. A lot of old systems will write pretty clumsy SQL, and I'm told that Gen AI can actually do pretty good at writing some SQL queries. So it's like you can use these aids to help you, but talk a little bit about why it's important to have an optimizer for your SQL, why it's important to make sure that's in place to get the thing running fast all the time. What do you think?
Yeah, very true. So, the crown jewel of any database system, just like you said, is its query optimization.
Right.
And they're typically what we would call a cost-based engine. Any kind
Mm.
of action you want to take in a database, let's say you want to lock some records exclusively, well, that has a certain cost. And so the optimizer will try to find the least expensive way to answer your question. And the problem is that sometimes we don't know what we're asking for in terms of logic. So, for an example, if you intuitively you would think that asking for a particular result set is just as easy as asking for the absence of that result set. So, if you said, "Show me all the salespeople who made quota," okay, so that's one select statement. But if you said, show me all the salespeople that are not in the group of people who made quota,
Hmm.
that's a much more complex query for the query
Interesting.
optimizer, yeah, to figure out. But if you're experienced and you learned a lot of the tricks of the trade, then well, that's something that optimizers have a hard time with. So I'll write a different query. I'll use a left outer join so that it doesn't need records on the other side to return the response very quickly. So
Interesting.
there's lots of examples like that. And so if you have a tool like our product called Plan Explorer that shows you where those issues are, because it looks at the execution plan of the query and highlights in red when something like that is happening. Or another example is it's common for databases to have to create an intermediate work result. It's a
Hmm.
big, 100-line query or 300-line query or what have you. And so it has to create a little small subset because you wrote a subquery in there. Well, it'll spin that out into tempdb, your temporary workspace. But if you do that too much, and tempdb isn't on fast disk, then you can actually, because you have something as simple as temporary work sets in the process of executing a query, overall performance can get a lot worse.
Right. Well, seeing you're reminding me of something that's very, very important, especially in larger organizations with a big production database. There are so many things happening all the time, and a human being is not capable of monitoring all that stuff individually. That's why you want this monitor in the background, just scanning for these things and looking and giving you warning signs, giving you early warning signs, right? Like I see you want to use the vacuum function fairly often to kind of clean things up. And I think a lot of old timers remember the defrag. Remember when you would defrag your disk, right? It's like, oh, my computer's running slow. I'm going to go and do the defrag. And you watch the little thing go. Tick, 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 tick. But it's
Yeah.
important to have that in the background to give you those early warning signs. Because if you miss them, if you wait, it's like anything else. If it goes code red, man, you're in deep, deep trouble. You're losing lots of money on your e-commerce or whatever it is. So it's just so important to know that, what do they say? A stitch in time saves nine, right? And
Right.
that's what you're doing with this technology, right?
Yes, and it's even more important in cloud computing. So when we have on-premises systems, we buy a lot of extra headroom in those servers. Most of the time you're not going to buy a new server and see CPU is 90% busy. It'll be 30 to 50% busy because we overbought a little bit.
Mhm.
But when we move to the cloud, you pay for every CPU cycle. You pay for the
Right.
IOPS, you pay for the
Right.
RAM. So if you write really sloppy code, it works. It returns a result set, and maybe it returns a result set in time that is satisfying to the end users. Let's say it returns data in 2 seconds. Okay, nobody's mad. But what if you could return that same data in 0.2 seconds? You
Right.
would save 2 seconds worth of compute, which
Oh.
cumulatively adds up to an enormous amount of dollars at the end of the year.
This is very interesting, and this is why it is important to know the details, right? And to also know, and maybe let's just quickly close off on on-prem versus cloud versus hybrid cloud. I think it's safe to say that hybrid cloud is the future, but I do believe that the rumors of on-prem's demise have been greatly exaggerated. And you want to understand, what can I do on-prem where I do have more control? Because once you go into the cloud, you don't have that level of granular control anymore. It's almost like going from a PC to a Mac, right? Where the Mac, they kind of lock stuff down and you just
Right.
have to deal with the interfaces. With the PC, you can do all kind of stuff, but you can get yourself in real trouble. So
Right.
I think it's going to be important to remember, on-prem has value. You can tinker more, you can do things more, you have more control. So don't think that you should just get rid of your on-prem. What do you think?
Yes, absolutely. It requires analysis, and I've seen probably maybe as much as a quarter, somewhere between 20 and 25% of customers I've talked to, mostly on the smaller end of the organizational size, regret the move.
Hmm.
And some have even said, you know what, we're going to repatriate. This is too much of a hassle. Our brains as a team is not in the right place. We don't
Right.
understand what it means to be cloud first, and so we're overspending constantly. We can't get it our hands around it. So let's build out a training plan and try this again in a couple of years. So it,
Yeah.
it definitely happens.
Yeah, you have to take your time, really think things through, make sure you have people on your side, and then use the Gen AI. I mean, this stuff can give you, really, even without loading your data into it, understand. You can just ask it all kind of questions and get all kinds of really interesting answers. I mean, it's like the great leveler of playing fields in many ways. This stuff is, but you still need to execute. You still need to do the work. You still need to play the game, as they say in the baseball analogies. But if you got someone like Kevin Kline on your side, folks, if you've got SolarWinds and all these capabilities, you're going to equip yourself to be able to handle what's coming. And, there's a lot of competition coming, and there's a lot of other bad stuff coming from the bad guys and the hackers and all that stuff. Well, look this gentleman up online, Kekline, Ke Klein, on all social media, on Twitter, now X, maybe Instagram, wherever it is, Ke Klein of SolarWinds. Thank you so much for your time. You've been listening to Inside Analysis.